This is my first talk in front of such a huge crowd, so don't be too harsh on me, please. Today I'm going to talk, as Christian already told you, about CI and CD, whatever this means for microservices, and how we deployed every Git push automatically to production. Just a short introduction about myself. So when I applied for this talk, I've been head of engineering at Gute Frage.net. But since the 1st of March, I joined the holiday check crew as an engineering manager. And of course, I have to do some advertisement, so work with us, just talk to me. If you want to contact me, just write me on LinkedIn, Twitter, whatever, you will find me. So today, there will be no rocket science. And there also will be nothing which can be cloned. So it's really a topic which is always a bit different from project to project. And I'm gonna show you how we did it for the Gute Frage.net website. Let's first start with some terms. Continuous whatever. So there are a lot of terms there. There is continuous integration. And when I speak about continuous integration, I mean integrating your changes frequently, so pushing at least once a day. Unit testing and building those pushes automatically of those changes, and fixing broken builds as soon as possible. With continuous delivery, I mean to ensure that every change can be deployed, but isn't deployed to production, but instead of into kind of a staging system. And on this staging system, the tests are changed automatically or by hand by the product owner, and so on. And on the top, there is continuous deployment, which means you actually deploy each change to production to get it out and learn fast if it really works, because you cannot be sure before. So I really like the sentence, if it hurts, do it more often. What were the goals and constraints when we started in early 2013 with microservices at Gute Frage.net? Before we had kind of a big PHP monolith from I don't know, 2006, 2007. So it was already quite old. We wanted that every commit is built and test. We wanted to do trunk-based development, which means no feature branching in your source code repository, source code SVC, but instead feature toggles, because we already did that in our old monolith, and we really liked working that way, so we just wanted to continue that in the microservice environment. One of the core benefits of microservices is that you can deploy independently, so you can deploy just the small part you've changed, and of course we wanted to achieve that, so we don't want to have to deploy the whole infrastructure when we change one service. And of course we wanted to deploy often, so it doesn't hurt so much. We also said we don't want any human interaction after push, which means not even a click on a button. So not even a one-click deployment. What we have also learned from the monolith is that we don't want to have a staging system, because a staging system only gives you valid if it's truly equivalent to the production system, and we believed we cannot do that. There will always be some differences. In the end, there is not that much traffic, and this makes a difference for your system. So with that, it's very hard to achieve to have a staging system similar to production, so we won't even try. And of course, for us it was also important to, when we deploy our microservice, we wanted to be sure that it's backwards compatible, so that every consumer of those services can still consume it, and we didn't break the contract accidentally. So at first I'm gonna show you how the pipeline did look like. Afterwards I give you some tips from the praxis, and in the second part I'll show you how we did feature toggling in a distributed environment, so in a microservice environment. So in the beginning, there is you, a developer, who wants to change something. that, we didn't want to do feature branches because we believed in more feature branching is less continuous integration. So we didn't want to get in this integration hell when we, not on purpose, but accidentally had a feature branch which lived for 2 weeks for one sprint, and then someone else did changes there, and in the end you have a huge mess and have to clean that up. But instead, we wanted to do feature toggles, which are, to be honest, which are just feature branches inside your trunk. So, so you integrate in mini steps. You have to integrate, otherwise you can't get your code into the project, but you do it in small steps, and the possibility that something big goes wrong and drifts into opposite direction isn't that high anymore. So, what are feature toggles? Feature toggle is basically an if-else. If the feature is enabled with a specific name, execute the new code, else the old code. If you have multiple places in your code where you have to toggle for the same feature, you just add this toggle with the full name on those different places in your code. I really liked the categories, so putting different toggles in categories, and the idea behind that. Because different toggles have different requirements to configuration, how they are managed, etc. So there are release toggles. Those are the typical toggles which are used for trunk-based development. You add a new feature, you add new code which is not ready from a technical perspective. So of course it has to compile, but it doesn't have to run, or is incomplete from a product point of view. You just add it behind a toggle, so you can commit it every time you want and push it without having any effect on your live platform. So it's in the code, it's deployed live, but it's not active, it's inactive, so it won't hurt anyone, but it's already there. This is one of the core principles of continuous delivery, is to separate the release of a feature from code deployment. So, for example, at GuteFrageNet sometimes it was very important that the feature may not go live until the community newsletter was sent out. So if we would have to do a code deployment, a timed code deployment, then you would need someone, a technical person, to do that. And we didn't want to have that, especially when if it's on the weekend. So with those release toggles, a product owner, for example, could just on the UI click the button and enable it for the users. On the bottom there is longevity and dynamism, so how long there is a feature toggle in the code and how dynamic is it. Release toggles usually don't live very long, so your goal is once it's live and it works, you want to get rid of the toggle in the code and clean it up. And it's usually also not that dynamic, so on different requests, usually it doesn't toggle its state so much. So when it's on, it's on. When it's off, it's off. Then there are A/B toggles, which are very useful if you want to do A/B testing and splitting the traffic of users into a group. So maybe you have some other A/B testing tools, but if you have feature toggles and implement a kind of configuration for A/B testing, you also gain A/B testing without an additional tool. They usually also don't live very long, but can be highly dynamic. So for the one user it's on, for the other it's off. Then we also had ops toggles, so toggles which change the operational aspect of a system. For example, rolling out a new feature step by step. So you want to test, does this feature work for 5% of the users? Does it work technically? Does it work from a product view? So do we have the same conversion in the new form, or can we stand the load in with our new service? Or emergency toggles. We had a toggle in our system, and this was actually in the legacy system. There we had a big MySQL XtraDB cluster. And in such a XtraDB cluster, surprisingly, things can go wrong. For example, someone does a not so good alter table on a big table, and suddenly your whole cluster doesn't work anymore. So we had an emergency toggle there, so to switch the DB connection from the cluster to a MySQL read slave outside the cluster. So when the cluster was down, we still could deliver content, but of course users couldn't create content, but we still could deliver content which was, let's say, 99.99% of the cases of the traffic was just reading content and not creating content. So those toggles usually live very long in the code, but aren't very dynamic. It can be considered as a circuit breaker by hand. And there are also permission toggles, so sometimes you want to roll out a feature just for specific user roles or permissions. Of course, this is very dynamic because it changed for each user. Why did I paint the longevity red? Because it depends, it really depends. If you want just for the rollout, you want to enable this feature at first for your administrators, then for your moderators or some beta tester group, and remove the toggle afterwards, then it doesn't live there very long. But it seems like, we didn't do that, but it seems like some people build up their whole permission and ACL system up on feature toggles, and then of course the toggle is there very long. I personally wouldn't do that because I like having it in the code, so I don't have to look into some external state how the system works. But for permission toggle, it really depends. Here's some examples of configurations which would be possible for a toggle, so on-off, percentage of users. What was very useful is IP addresses, so we were able to enable a feature just for our office IPs, so just for internal use, or start-end date if it has to be timed. User-users group or cookie code was also very helpful. For example, we had some integrations of a tracking pixel or whatever, and we wanted to give a partner the possibility to look to get this the page with the toggle enabled, which is responsible for the tracking pixel. So we could just send them the link and tell them, hey, set yourself this cookie with this name and this value, and you will get the new version. And test it and see if the tracking works for you. I can tell you what we did at Holiday Check right now, where we just start feature toggling. For example, a test entity. We have on our system, we have a hotel, it's called Test Dummy, it's just for testing. And in our service, which is responsible for creating hotel reviews, we can enable a change for this funnel just for the Test Dummy hotel, which actually isn't hit by any user because they cannot find it, but we can then test it on the Test Dummy hotel. And this is quite handy. Of course, there are some do's and don'ts for feature toggles. They don't come for free. What you really want to do is speaking names. What we did is we always had our gyro number in the name of the toggle or the identifier of the toggle, and then some short description like the title of the gyro ticket. What's also very important is to add removal nodes. Of course, when you integrate the toggle, sometimes in the enabled state, some code is getting obsolete. So it hasn't to be just the code in the else branch, but it can be also some other classes or function which are used only by this specific part of the code. And when is the time to think about what can I remove when I remove the toggle? I think it's important to think about it when you add the toggle, because then you're really into the code. And when you remove it, it can be 2 weeks later. Then either you don't remember what can be removed, and then you have to investigate again, or even someone other is removing it and has really problems to understand what else can be removed. So what we did when we integrated a toggle and identified some code which can be removed after removing the toggle, we just added a short comment with the name of the toggle and a note, please remove when removing the toggle. So that it's very easy for someone to remove not needed toggle later on. So he just has to search, a full text search on the toggle name, and he finds everything which has to be done. Or even start removing here and stop removing here, something like this. What was also very useful to have kind of a history of toggle changes. And I think we did it in a quite lean way. We just had a Slack integration. Slack is a chat, I think everybody knows that. That every time someone changed the state of the toggle, then in a specific channel in Slack, there was a small note, xy changed toggle set from state A to B. So this configuration was before, this is afterwards. This was enough for us because the Slack channel is archived and you can search in there. What you also want to do is expose and monitor the state of the system. So this is especially important for microservices, that you somehow, the microservice has to expose with what configuration am I working, and is my configuration up to date. So that you can identify if something goes wrong, is it maybe caused by the state of the toggle configuration. And I think the most important thing is to keep it simple, because it has to be, if a human looks at a toggle configuration, it's very important that it's for a human very easy to determine when is this toggle active for what kind of requests and when is it not active. If you have too many configurations which somehow affect each other, so for example, what configurations did we have? It's online but just for 5% users, and they have to be in the user group admin and have to have a cookie. Then somehow it's very difficult for a human to say, okay, no, it's active, no, it's not. And what this leads to is that it's more likely that you will have bugs in your implementation of the toggle checker. There are also some don'ts. We once had over 150 toggles currently active in the system. And this was way too much. And then, because you have to test both states of the toggle, unit test it, and then you have a lot of tests and you have a lot of possibilities how your code can be run through, and nobody has an overview which toggle is still needed and which is not. So what we did then is we limited it. So we started with 150, and each week we reduced the amount which can be created to by -5. Always reduce it -5 week by week. And then if somebody wanted to add a toggle, and people really were used to adding toggles and they really liked it, and so, but then they had to remove some before, which usually is a task of 10 minutes per toggle. In the end, what did fit very good for us was 42 toggles on the whole system. This was a good size for our system, which consisted of like a monolith, 30 microservices, 2 apps, and 4 teams developing in it. 42 was quite good. You could also limit it by 5 per team or 10 per team. What's also really important not to do is dependent or nested toggles. Let's start with nested toggles. Nested toggles means you have a toggle if, and then there again is another toggle which switches the state, and maybe again another one, and this leads to a very complex behavior, how your code works at all. And of course you want to test each state, and then you permutate the amount of tests. You're going to see the latest. You're going to see it in your test that you have too many toggles which are nested. So what we said, we don't nest toggles at all. Or dependent toggles, I wouldn't also do that, because dependent toggle means that if I change one toggle, I also have to change the other toggle. And this also makes it very complex and very likely that something goes wrong. And the last thing is very funny, toggles which are not working in both states. So there were very often the situation when I wanted to switch off a toggle, and then someone was crying, please don't, it's active since 2 months and I'm not sure if it works when it's off. then I ask him, so why do we have a toggle there? If we cannot switch it off, if we cannot use it, just kick it. Then it's time to kick it. So once we integrated our new code behind the toggle, we were just commit and pushing it to origin master. What did happen afterwards? At first we had the test and build step. I think this is very common for every project. So linting, code metrics, compiling different tests which don't need a running instance. So running the service, just in-memory things. And at the end, maybe publish your artifact. So nothing special here. The next thing is just deploy to production. But just one instance and no live traffic, so the baby has to learn to swim. You somehow, in your microsystem environment, you have to identify, is this the one service which is live, which may not have live traffic? If you have DNS-based service discovery, you could have it behind a separate host name, maybe, a different host name. For us, we had a service registry based on Apache Zookeeper. That's the default for Finally framework. There we just had a different path, where this a sub-path where this services which were live but may not have live traffic lives. So why do we deploy a service and not give it live traffic? At first we want to see, does it start? Is the health check green? What I forgot that I have this slide. Where did we deploy it? It's maybe interesting. We use Apache Mesos, which is a framework to abstract the hardware from in a hardware cluster. So you have just resources and allocate them. For example, you can say, okay, each service has to run on 0.5 CPUs and 512 megabytes of memory. And on top of that, there is this Apache Aurora project, which is a job runner for long-running tasks like a service or cron jobs. So this is just the runner, which just looks, are the jobs running? If some job is dying or some instance of a job is dying, it restarts it and so on. So the question was, why did we deploy to production without live traffic? We did something I call black box testing. There are different names for that, like smoke tests or whatever. It's just testing the new service from the outside. So we use this new instance and have a separate test suite for those tests to see, does it work? Are all dependencies reachable? Do requests not throw any exceptions and so on? So what we didn't want to do is testing. We didn't want to test business logic there. Just does the new instance work on a higher level of view? What we learned that it's important because now we are in production, and there it's important to somehow separate the data. So if you just read data, it's easy. If you create data, you have somehow identify, hey, this is data created by my automated test. For Gute Frage.net, this was quite easy because we already had a multi-tenant system. So there is Gute Frage.net, there is Sportlerfrage, Motorradfrage, Autofrage, Gesundheitfrage, and so on. So in each of those, for each of those, the data was separated in the database. And each service was capable of dealing with these multi-tenants. And what we did is we just added another tenant, a Testfrage tenant. So we had a tenant which was just for testing on live. I wouldn't recommend to build a multi-tenant system just for the sake of black box testing. Then you have to do it in a different way and get creative. So another example I already mentioned was at Holiday Check we have this test dummy hotel, which is a test entity, and so everything which happens there cannot be seen by the user. So we can create as many hotel reviews as we want to, we can create as many pictures as we want to, and if we see one time, oh, we are creating so many data, it's not handleable anymore, a database, which doesn't happen because our users even create more data, then we could do some kind of cleanup job or whatever. It's also very important to create all necessary test data via service calls. So, an example from Gute Fragenet, if you want to test your create question service, and you need a user who creates the question. So you shall not rely that there is a specific test user, because on a local machine, if someone executes the test, it may be not there. So you may not rely that there is kind of a fixture for your test, but instead we said, okay, everything what's needed for the test to be run should be done via other service calls. So in the question example, at first in this test we went to an any live question service which was there, user service which was there, and created a user. And afterwards with this user we created a question. After the black box tests were green, we did consumer-driven contract tests. Consumer-driven contract tests means every time someone consumes a microservice which you are responsible for, he has to provide you a test suite which you can run. And this test suite should just test that the service works in the way the client expects it. So, is the request format as I expected? Is the response, are the responses as I expect? And if the client has special, oh, now I got louder, special requirements for latency or throughput, then they should also test this, that the service answers within 50 milliseconds if it's important for them. And each time you deploy your new commit, you run all the consumer-driven contract test suites you got from your consumers in your pipeline. And your consumers are responsible for keeping them up to date, and they should provide you somehow some kind of artifact which you can run. And it's highly recommended that this artifact can be run always in the same way, so you commit on kind of a standard there. Like there is a start shell script, or everything is or if your whole infrastructure is on JVM based, then it's a jar which you can just execute, or maybe some Docker-based solution that you can containerize it and somehow abstract the way how the tests are run, because this can be very different for a service or for the iOS app. If the iOS app uses your service, they're going to provide you some kinds of tests, and maybe they are Objective-C, and you don't want to have to run every test in a different way. So committing on a standard how to run those tests is recommended by me. So, and if all tests are, all consumer-driven contract tests are green, so you can run them in parallel, this shouldn't take so long. Then afterwards we did something which is called a canary deployment, which means just give the new instance some traffic and monitor how the CPU usage, the business KPIs, memory, the exception or error rate is, and if it somehow differs to compared to the other instances which are live. So if all instances which are live have an error rate of 1% or 0.1, let's say 10% errors in the logs per request. So every 10th request there is going to be one error in the logs, and your new service suddenly has every request an error in the log, then you probably know there's something wrong. So you have to build a system which automatically checks those metrics, and this can be very sophisticated and very complex, and I think this is even the most complex part in the whole build pipeline, to have something smart there, which really detects if something goes wrong, but has too many false positives. I really like the idea of also measuring business KPIs. So if it's still performing the way you expect that it expects, or if it's, for example, for a service which provides a search, you want to see if maybe the conversion is of the clicks in the search is better or worse with the new algorithm which you just deployed. And here you also have to think about backwards incompatible changes. So if you want to change your schema of your service, so the data schema, if you have one, and want to change it in a backwards incompatible way, you cannot do that, because you will have, at minimum, in this case, you will have 2 different versions running live concurrently. So if you want to do a backwards incompatible change, there you have to do it in 3 steps. So just creating a parallel structure and synchronizing it, and then migrating everything, deploying the new service, and in the next deployment removing the old stuff. This is just the way how you have to do it. And if the canary deployment is okay, so if your job is thinking, okay, this instance behaves with live traffic as good as the other one, or not too bad, of course you're going to have some tolerance, then you can go live. What was very easy for us at Good, we had a lot of traffic. So if we say we have this new service and give it 5% of the traffic for 5 minutes, there were a lot of requests on this service. But if you don't have that, for example, at Holiday Check now, for the service which is responsible for creating reviews, we have 2 reviews per minute, and on all instances. And then it's going to be very difficult, or you have to let it run for a very long time until you have relevant data to determine if does it work or not. So this is not an option in this case. Then you have to think about other solutions, like, okay, we want to replay traffic which we recorded previously. Of course, you have to somehow handle the case. If you write something, it has to be idempotent. So this is going to be a bigger challenge if you don't have so much traffic on this service, or if it's a service which is just on the edge of your system and it's not getting so much traffic. But if it's not getting so much traffic, maybe it's not that important. And now, after the canary is successful, we just put the new version live and on X instances and shut down the old instances. Yippee. Yippee, because the work doesn't stop there. You have to do monitoring and alerting. You have to be very good at that. So it will happen that you still release bugs. You cannot avoid that. So at least you want to be notified very quick, very fast when something went wrong, and then you can react on that very fast. This is not a dashboard from us, it's just from the Grafana website. Today I added a screenshot from a dashboard I did today at Holiday Check. As an example, we there just, what did I do? I wanted to have the laser pointer. There it is. We have some KPIs. So successful hotel reviews. So what's the result of the service? And at the end we have hotel reviews. So if anything before breaks, we won't have a hotel review. So I think that the most important metric is the KPI at the end. So if we see suddenly there are no hotel reviews anymore, then something is wrong. And down there we have, for example, we added the HTTP response codes from this service. As I already said, this service doesn't have not that much traffic. So we have the 200s, which are the yellow line, and 400. So we had kind of a lot of 400s there. This we have seen, and which was very helpful to have this metric down there. So there we have the request time. So how long does a request of a downstream service, a service which I use from my service take, and you see there was kind of a peak in the authentication service. So something was wrong with the authentication service, which led to unauthorized or forbidden. Maybe it should be even an internet server error, but that's another story. We also have the response times here. So you have to start small there. So this is a small, easy dashboard, but also already gives us a lot of traffic. And this is just based on Grafana with a Prometheus backend behind it. Prometheus is kind of a tool or ecosystem to gather metrics out of microsystem environments. It's made by SoundCloud originally. I think it's coming from SoundCloud. And they even have an experimental feature for alerting, where you can set up alerts declarative. So you can say, if this metric drops below this value or for 5 minutes, then alert me in some way. For example, write a message in a Slack channel, or trigger a PagerDuty alert if it's something which is is more severe. So that's what we're currently experimenting with at Holiday Check. So let's see if we hit our goals. We can now build and test every commit, which is immediately deployed immediately. So it usually takes 20 minutes, deployed to production, until all of those steps are done. We have feature toggles, so it's deployed on production, but it's not released to the user. We can deploy each service independently without human interaction. We don't have a staging system because we test on live, and we test our changes for backwards compatibility with the consumer-driven contract tests. Here's just some slides which I couldn't fit anywhere else. Microservices means more of everything. You usually will have more code repositories, you will have more pipelines and more builds and deployments. More pipelines, for example, I could define it, again, 30 services, and I think in the pipelines there were 6 steps, so you had 30 times 6 jobs, we had that much jobs in our Jenkins, which means some work for the Jenkins. And of course, every time someone commits, there's a deployment, so you need a huge amount of slaves which handles those builds. do is to automate everything. So if you create a service, this has to be automated, and there has to automatically be the build pipeline available. And I also recommend to have the configuration of the pipeline somehow in code and versioned, so you can see what changed when. I think for the new Jenkins 2, there's even the possibility to add the configuration of a job of a project in the repository of the project, and it will automatically read it. I've heard that today, but I didn't use it yet. Okay, thank you. What we decided that we want to have a homogeneous deployment and operation. So we wanted that every service has kind of a similar deployment pipeline and does again work from the outside the same. So how starting the service should be somehow abstracted, and there should be a common interface how the Jenkins can start this service. For us, this was very easy because we only use JVM-based services. If you have different technologies, like you have a Node.js there, then you again have to think how to abstract it, maybe with Docker. We used the Jenkins build pipeline plugin, which was very handy. So this again isn't a screenshot from us, because I don't work there anymore, I cannot do screenshots. This was a problem for me. Yeah, this build pipeline plugin supports you just this overview here, and that you don't have to click through all these jobs and then downstream project, downstream project, downstream project, but instead have everything on in one view and see, okay, what is currently running in my build, and if something failed, you see it immediately. I already mentioned that you have more of everything, then you have more jobs which can fail, and keeping somehow the overview about that can be difficult. That's why we had this extreme feedback panel, and maybe some of you know it, which is just a panel which sorts failing jobs to the top. So we had this on screens in the office, and if a job failed, then it was on the top and red and blinking and do something, just fix it. I also have seen this. This is the delivery pipeline plugin for Jenkins, which I haven't used so far. And I think the new Jenkins version also has more support, onboard support for delivery, for pipelining. We just used Jenkins because we knew it, I think there can be better choices. So other tools which does even have better pipeline support or so what, but we were happy with Jenkins because it worked. It isn't perfect, but it worked. So how did our feature service look like in the distributed environment? The feature service had 3 interfaces. On the one hand, it had a classical HTTP REST interface to create, read, update, and delete features. Why is this R in bold? Because the reading was the only thing which was used by something outside of the service. Create, update, and delete was just used by this toggle dashboard, which was the second interface. So a UI for somebody who wants to toggle a toggle. This UI was, again, no screenshot, I'm sorry. This UI was just a list of toggles, and when you clicked on a toggle, you had the list of configuration for this toggle, where you could just change the configuration. And somewhere on the bottom was a big publish button, and then the changes were published through this system. We also had a third interface to that service. It was Apache Zookeeper based. So Apache Zookeeper is basically like a tree. So you have a root node, and then you have different paths where every leaf and node can have data in it. So we just had under the path /features, there was a JSON which represented the latest state of the configuration. Why was Apache Zookeeper so useful there? Because for our services, they used the data in Zookeeper as an interface, because Apache Zookeeper allows you as a consumer of data, as a reader of data, to add on watch on a specific node. And every time anything changed in this node, so the data changed, it gets children, the node is removed, or children is removed, all readers which are watching this node are getting automatically notified. So there is a kind of a push to the services of changes. And so the services didn't have to constantly poll to identify if there's a new configuration. We couldn't do that for our legacy application or for the mobile apps. There we just had a get features endpoint in this service, and it was delivering the same JSON as in Zookeeper. And as an example for the mobile application, they they fetched this configuration once they started. So when the app was started, it was working with the configuration the whole time. And if the user minimizes it and puts it back into foreground, it was also asynchronously, one-time fetching asynchronously the new configuration. How did the implementation of the feature toggle checker, or the components which were checking the feature toggles look like? So what you have to do is that each consumer has to have a toggle checker, so a component which can read the configuration and decide based on that, is this toggle now active or not. So we had to duplicate this logic in all consumers, because it would be very inefficient to have some kind of network I/O for checking a toggle. So checking a toggle can happen over and over again. In one request, maybe 10-20 toggles are checked, so you don't want to do a request to the feature service each time, but instead you want to decide that locally. What you have to think about here is how to invalidate the cache, which caches the configuration of the toggles. This is very easy for Zookeeper, because you don't have to invalidate, you get changed pushed. For other applications or projects which weren't connected to the Zookeepers, we were just, as I told you, for the iOS app, doing it on foreground or doing it constantly in the background every 5 minutes. which means it can take up to 5 minutes until the configuration is active in that part of the system. You also have to be aware of that you have to do per request decisions. So if you, for example, if you want to toggle based on the IP of the user, and that's in a component very deep in your service, probably you won't have the IP available there because the request context is at the beginning and you don't propagate it through your whole service. So you have to think about how to solve that. For example, with some kind of global request state or whatever. We used, in Scala there's something called future locals. It's similar to thread locals, so within one future you can set a variable which has always the same state in this case in the whole request. This is also very important, error handling and self-healing. So as on the example of as an example for the services, what can possibly go wrong with the toggling system? It could happen that when you start up your service, you cannot connect to Zookeeper. The node is not there, so the features node in Zookeeper is not there. It has corrupt data which you cannot parse. So you have to think about, what do I do then? When this happened on startup, we just didn't start up the service. So the startup failed and the health check never got green, so the deployment failed. Because we couldn't automatically decide in what state do I want to start the service. So do I want to have every toggle active, which can be a bad idea, or do I want to have every toggle inactive, which can be a bad idea? So we just decided to not start the service at all if there is an error. Of course, this can also happen while the service is running. So suddenly it loses its connection, or the node gets deleted in Zookeeper, or whatever. And then we decided to the service just continues working with the last known toggles configuration. So the last configuration which was valid was then as long valid as the problem was fixed. And the problem was fixed means the service has to have some kind of self-healing, so try after a delay again to read or to reconnect or whatever to see if it now can parse the content of the configuration and try that again and again. And if something goes wrong, you also want to monitor you also want to monitor that to determine if something goes wrong and alert yourself. So if some instances of your service suddenly don't have the actual version, the newest version of your configuration, you want to somehow know that there's something wrong, so you can fix it. So monitoring and alerting was for us a first-class decision. We implemented in the services, implemented it that way that every service had to expose on a special port endpoint to where the information about the health of the feature toggling system, and this service was exposed. So am I connected? Can I read the data? What's the latest version? Because maybe the service just think it's connected, but it actually isn't. And then you can compare, is the version there, my actual version, and see if something goes wrong. So that's it from my side. I'm happy to answer your questions, and just want to ask you how you do that in the Microservices environment. Thank you for listening.
So I have a question. So, simple question. How do you code reviews if you don't use branches?
Yeah, thank you that you remind me. I forgot to say that. Of course, then we did code reviews only when the code was already in production, which is not a problem because it's not live. And if something severe is failing, your good test suite should catch that anyway. We used a tool called Crucible, Crucible from Atlassian, and there you can, after you committed your stuff or did your task, for us, a task usually shouldn't take more than 1 day, so you had 2 to 3 commits, and you just added those commits to the review and gave it your team. So the review was actually post-production, but pre-live, and this worked pretty well for us. Did that answer your question?
More or less, yes.
So what's the less?
Do you think in retrospect it was worthwhile putting in all these feature toggles, because it seems like it adds a tremendous amount of complexity to the system, and having 150 feature toggles in the system is mind-boggling, this complexity, and I cannot imagine that you can test this. Even reading the code, having all this boilerplate, ifs and else, is this feature toggle enabled or not? So was this worthwhile? And the other question you made a decision not to have a staging system, which created a problem for you, and you solved it by deploying something on a live server which is not getting any traffic. So that sounds like it's a staging system, more or less. Do you think going back to the decisions you made at the outset, was it really worthwhile, or would you do things differently now?
For the first question, as I told you, 150 toggles aren't a good idea. So you have to get discipline there, so you don't have so many toggles. So before you create new toggles, just remove the old ones. In the end, we had on each service, we had 0 to 2 toggles, and that's definitely handleable. It's not that complex, and it's not adding toggles which is complex. The thing you have to think about is it's worth building such a system. This is more work to do, but if you do it in small steps, start very small. So at Holiday Check we just started with toggles which cannot be switched or toggled when the service is live, which would need a new deployment because they were just in the code. So we start very, very small, and then it's not very complex, and then you can learn and adapt it in the ways you need. And you should stop at the point where you don't gain anything more by adding more complexity. So of course you have to somehow compare the costs and the benefits, but I still think we improved a lot with feature toggles. So our delivery was in the end a lot faster. We learned faster if our features actually work. So we learned from the earliest possible point of view. We learned that it's really working in production, and not at the end of the story, maybe if your story takes too long after a week. So this helped us a lot, and it was also worth doing it because we solved, as I mentioned in the beginning, we solved different problems with one technique. So how to do trunk-based development, how to do A/B testing, how to roll out features step by step, and many things more, and doing timed releases. So releases just Sunday, a feature has to be released Sunday at 8 p.m. and so on. So we gained a lot with one technique, and that's why I still really like it and would do it again. I'm actually doing it again.
Feature toggles are addictive.
Yeah, they really are. And when I started at Gute Fragenet, I have to admit that I first thought, oh god, they are crazy, why do they do that shit? And after I used it a while, I really got into it. So I think you have to experience it.
Yes, try it. The first time you reason about feature toggle, you think about the exponential growth of feature toggle combinations and all those things, and actually it is just a quick raise of hand in between. Who's you? No, not who's asking a question, but who is using feature toggles? Who is using feature branches? Okay.
It's maybe 40, 60.
Yeah, so we are on a good path, so it will get better. For everybody who uses feature branches, just, if you want to take one thing away from this evening, look into feature toggles. It makes your life and the life of your services easier. And the second question asked was about the staging.
About the staging system. Yes, it's of course we ran into this problem to have some kind of staging data in the live system, but honestly I've never seen a staging system which actually worked the way the production system worked. I've never seen that, and I think it can also on the other side it does also need a lot of work to create a staging system, or can also take a lot of work to create a staging system which mirrors the live system.
No, but if you want to just make sure that the server starts up.
What?
I mean, if you just want to make sure that the server starts up, if you do it on the staging system, you need to deploy it on the live side, right?
But are you then sure that the live configuration of your database is valid? I wouldn't be. So if it starts on staging, I wouldn't be sure it starts on live, because there are differences.
So the question from my side is, well, from the whole, I would love to, like, if you shared some numbers about how much releases you do and how many teams, how much how big is the team that maintains all this? And the second question is, how do you imagine refactoring the system in this setup?
So how big was or is the team? It were four development teams with 4 to 6 developers each for the whole platform, so not just for feature toggling. And they did it in their, so we didn't have a separate team for doing feature toggles. So we had just teams which are building the product, and they have shared code ownership over the whole system, because with 4 teams this is still manageable. Maybe with more teams you really need responsibilities. And so we didn't have someone dedicated to build the system, and of course we started at a very low level and had it very small, and then just every time we thought, hey, this could be cool, and it could be valid doing it that way, and we needed, we just added the functionality there. So it just grew over time.
And the second question?
What was the second question?
The second is about, so obviously you have the live system and you test in live, but I don't see it really obvious how it is possible to do refactoring of architecture or something like that.
Sometimes you cannot toggle it. There are cases where you cannot, or you can't toggle it, and then you have to just be key. So that's what we did, we just released it, and we just trusted our tests. Of course you need a good test suite. We trusted our test that it works, and but the most times you actually can toggle it, even big refactorings. So what we did on a big refactoring, we just built up a separate structure, so a separate, let's say you want to refactor one component with 5 to 6 classes in your service. You just build up its parallel on parallel quasi is sorry. You want just build it up together and leave both there, and on a strategic point where this component is used, you just have the feature toggle. If toggle is active, use the new one. If it's inactive, use the old one, and then you're very safe. You can switch on your refactoring for 1% of the users and can see if it works. Or if you refactor the whole service, then just add in the old service, add something like, if feature is active, forward the request to the new field service. Otherwise, handle it yourself. Excuse me? Exactly. So that's how we did refactorings there, and I even feel more confident having a big refactoring behind a toggle, because then I know if something goes wrong after one day, because there is a memory leak, for example, I can just switch it off.
My question is, you mentioned both A/B testing and feature toggles. In my worldview, a feature toggle is really just a primitive version of A/B testing, and I actually prefer a sophisticated A/B testing framework because it's not binary, right? It lets me, gear things up and down. And for me, A/B testing has really the notion of I want to learn something. This is not just because I want to toggle things back and forth, but because I really want to see what works better. So did you run this completely separately, or do you see this the same way that they're closely connected?
I just think we didn't do such sophisticated A/B testing.
You should.
I'm not. I don't think that you always should, because sometimes you lie to yourself. That's what I experienced. Yes, we did basic A/B testing with it. So just splitting the users in two groups, and the user in one group always gets the same version of the toggle, and then we could identify in our data which data came from which group, for example, and could see if it performs better. But of course, a more sophisticated A/B testing tool can do much more, but we didn't need that.
A little tale from Auto's card on that one. Feature toggles are a very powerful tool, and if you explain to your product guys, now you have an if statement in your code that you could use, and the danger is they're going to misuse it. So the first thing they're going, I don't know what to do about it, but please don't remove this feature, I can switch it on and off however I like, so it stays there forever. Then you accumulate 150 of those. And of course it could be used for A/B testing because I can switch the toggle on and off for other things, but then you're missing out completely the statistical part. Beyond that, A/B testing is about measuring and not only about turning off on and off things. Then it could be also an opt toggle, it could be an experiment toggle, it could be a permission toggle. In essence, be aware that this is in the end just an if statement, and don't blindly give if statements to product people or to other guys who want to fiddle around with that stuff. So this muddles the waters to be clear about what is a release toggle, which is only in there for temporary, and what are different use cases, and therefore, for example, A/B testing, just because it's an if statement, it's not necessarily conceptually the same, just by technically the same. This is important.
Chris? Since you mentioned that, how do you actually drive the removal of the toggles in that code? Like, especially if business said, well, we might going to need this in like 6 months from now, and if you don't remove them, you end up in spaghetti. So how do you actually drive? Who drives? What's the time frame? Is there extra user stories to do that?
So there were several. If I understood the question correctly, the question was, how did we ensure the toggles get removed? Or?
And the dead code.
And the dead code, yeah. The dead code is simple, add removal nodes. If you don't do that, there could be dead code. So again, feature toggling is also about discipline. And how did we do the removal? When we had sprints, which we stopped after a while, we just planned, each sprint we had a small story or task or whatever to remove toggles which weren't needed anymore from the former sprints. When we didn't have that, when we stopped doing sprints, because we worked more in a Kanban style, then the limiting of the toggles really helped us, because then when someone wanted to add something and we hit the limit of 42, he had to remove one first. And usually he just had to ask in his or her own team that if there are toggles which can be removed, because they're always there. So it was very rare that you actually had to go to other teams and ask which of your toggles can I remove. So this just worked for us. Putting a limit inside and everything was fine.
Hi. I had also more like a comment, not a question. Well, first of all, about this question of whether you use feature branches or feature toggles that not exclude one another. In my mind, I had experience where we use both. For instance, to avoid this post-production reviews. And once we used feature toggles, and then it slowly became like a features that we sell to our customers. So basically we turn on the feature when the customer pay us for like file quality stuff. Yeah, that also.
Yeah, these are the permission toggles I mentioned at the beginning. We didn't do that, but I read that some people are doing this, but we didn't do that, and I think I wouldn't do it that way. I wouldn't abuse feature toggles for that.
First of all, thanks for the talk. I really like the presentation. The question is, did you have experience in rolling out features to multiple regions or data centers? And how did you toggle that and roll it out in this case?
We had just one data center and had a Mesos cluster there, but I'm not into the operations so much, so I don't know if you would have multiple Mesos clusters if you have multiple data centers. So I have no experiences on that.
There's an interesting paper from Facebook, I believe, published in the morning paper, how they do their configuration management and how they publish their feature flags. And they have quite a sophisticated setup to do that in a timely manner. So this is not one of those easy things, but if Facebook can solve it, we all can solve it.
It cannot be that hard. They use PHP.
There was another question. Yeah.
I'm using these feature toggles for 15 years or more, and I was working in the telecommunication environment. So we had big, and then the display screen, what you mentioned with the product, and this is a nightmare. We had some thousands of features you could switch on and off, and after some time you're scared of changing something because you don't know the impact it has on anything else. So if you can, try and get away from that.
So you mentioned these if statements, and if statements work great in your application code. How about configuration? How about CSS or JavaScript, which is an asset that, yes, you can put if statements, but you don't want to like load things conditionally, like that would affect performance. How do you extend your feature toggles to these kind of settings?
Yeah, this is of course not that easy, but it's solvable. So for CSS classes, for example, if we had to toggle CSS classes, we just copied them and did our changes, and if the toggle is on, we have the new version, the new CSS class. If it's off, we have the old CSS class. And there again, mark the old CSS class with a removal node, so it's getting removed when someone removes the toggle. The other thing was configuration files. Yeah, that's actually the most difficult one because you cannot do an if statement there, but what you can do is add another configuration key. So if you want to toggle, for example, your database configuration, just do a database configuration new and an old one. And toggle which configuration key is used in the code. So, and the third thing was JavaScript. Yeah, JavaScript is very interesting because I think in the front end it's much more difficult when you have page cache. This really hurts. So this would mean if the first time a user hits the page with a toggle state and your server renders the HTML or whatever delivers the JavaScript in some way, it would deliver it always the same, so you lose toggling. What we did there is for toggles in JavaScript, which we had and used a lot, we delivered the configuration for this request via an edge side include, with varnish. So each request we had an easy tag there to get the configuration, the actual configuration, and in the JavaScript we had again a feature switch checking component which works with that configuration, and of course this works different than server side. And the other thing is if you render your HTML server side and have a toggle there, page cache will really hurt you. So for our case at Modified, we were lucky that, lucky depends on, 99% of our requests were from logged out users and those were cached. So we just were aware that we cannot do toggling there. And for all our logged-in users, where we did the most features, so they were the most features for all the logged-in users, they didn't have a page cache, so everything got delivered live for them, and so we had no problems there. But of course, if you have to solve that, if you want to solve that, you have to fix somehow to add the toggle state to your cache key of the page cache or so what, but we didn't do that.
So I believe we do a final question afterwards. I believe you will stick around for some more questions, but one final question.
You said Jenkins is not your favorite CI tool, so what are you missing and what's your favorite?
I didn't say it's not my favorite. I said I don't think if it's the best choice. I don't know if it's the best choice, and I don't know. I never evaluated something else because we were just defining it. We were using Jenkins because we already had it, and now I'm on holiday check. It's the same situation, but but there are people telling me that hey, we could use this and this and this, but I've never used something else. And as I told you, Jenkins just worked for us, but maybe there are better choices. I don't know. Travis CI or how is this called, for example? I don't know. As I told you, I've never used anything else than Jenkins. Jenkins just worked for all the cases we needed. But I can imagine there are tools which work better.
Okay, thank you very much for a great talk and a great Q&A session afterwards. And stick around and discuss the advantages of feature branches and or feature toggles and where your staging environment should be gone by now. Thank you very much. Bye.